laboratory. To prepare soap, we will run a reflux heating setup. The setup is formed by a heating mantle, a round-bottomed flask, a fractionating condenser. Reactants to be used are 20 milliliters of sodium hydroxide solution of concentration 8 moles per liter, 20 milliliters of olive oil, and 20 milliliters of ethanol. The role of the ethanol in this mixture is to ensure a good contact between the reactants of this reaction. Pour the sodium hydroxide solution into the round-bottomed flask. Then the olive oil, then the ethanol, add a few grains of pumice to homogenize the boiling temperature in the flask while heating the reaction medium. Start heating the reaction medium while introducing water into the condenser. Note that water enters through the bottom hose, goes up into the condenser, and gets out through the top hose. Heat the reaction medium for 30 minutes. The mixture starts boiling. Observe the reflux. The vapor leaves the reaction medium, rises in the condenser, comes into contact with the wall which is being cooled by the circulation of cold water, condenses, and then rejoins the reaction medium. At the end of the heating, cool the flask in open air. Then under tap water, and finally in a cold bath containing water and ice. To recover the soap, pour the mixture over a concentrated solution of sodium chloride. Soap is insoluble in the solution. It precipitates, and we obtain two phases. This is called salting operation. Filter the mixture using a Buchner funnel. Rinse the obtained soap with water and leave it to dry.
Each molecule is composed of a long, non-polar hydrocarbon chain, which is hydrophobic in nature, and a short polar head, which is hydrophilic in nature. The hydrophilic end is attracted by water molecules, whereas the hydrophobic end of the molecule is repelled by water but is attracted by non-polar substances like oil. The cleaning action of detergents and soaps is attributed to this special feature. Have you ever wondered how soaps and detergents work to get rid of dirt and grime? Here's how. Dirt or grime generally has an oily component. Water cannot dissolve oil, and hence water by itself cannot take away dirt. This is where soap or detergent comes of use. Dirty clothes are soaked in water containing soap or detergent. When detergent or soap molecules come in contact with the oil or dirt on the fabric, the non-polar portion of such molecules attaches itself to that bit of grime or oil. Over time, more and more detergent molecules gather around it, and a micelle is formed with the oil or dirt inside it. A micelle is a ball-shaped collection of detergent or soap molecules with the hydrocarbon ends clumped together on the inside and the polar heads on the outside. Eventually, through either agitation or stirring of water or rubbing, these micelles are lifted off from the fabric surface and get into the wash water. Remember that because of the charge on the heads of the detergent molecules, the outer surface of the micelle is charged. Since these micelles all have similar charges, they repel each other and remain suspended in the water. These get removed when the water is drained off. Repeated rinsing and wringing remove all such micelles and make laundry crispy clean.
You know that the best way to prevent the spread of coronavirus is to wash your hands.
Wash your hands.
Wash your hands!
But why? It's because soap, regular soap, fancy honeysuckle soap, artisan peppermint soap, just any soap, absolutely annihilates viruses like the coronavirus. Here's how. This is what a virus, like coronavirus, looks like. It's a bit of material surrounded by a coating of proteins and fat. Viruses easily stick to places like your hands, but when you rinse your hands with just water, it rushes right over the virus. That's because that layer of fat makes the virus behave kind of like a drop of oil. You can see it happening in this demonstration. Oils are just liquid fats. What happens when you pour oil into water? It floats. It doesn't mix. But add soap, and suddenly that fatty oil dissolves into the water. That's because inside, soap has two-sided molecules. One end of the molecule is attracted to water, the other end to fat. So when the soap molecules come in contact with water and fat, these dual attractions literally pull the fat apart, surrounding the oil particles and dispersing them through the water. Let's go back to our coronavirus molecule with that layer of fat holding everything together. When it interacts with soap, bam, that fat gets pulled out by the soap. Soap literally pulls apart and demolishes these viruses. And then the water rinses the harmless leftover shards of virus down the drain. But, and you know where I'm going with this, it takes time for this effect to happen. 20 seconds to be specific. To show why, we ordered this lotion that mimics viruses and their fatty layers. It glows under a UV light. If you just rinse your hands under regular water, nothing comes off. If you wash with soap for just 5 seconds or 10 seconds, your hands are still covered. The virus is still there, able to get you and others sick. But 20 full seconds, now the soap is actually destroying the virus. Hand sanitizer works too because it's mostly alcohol, and alcohol works in a somewhat similar way to soap, breaking down that fatty layer. You need a high concentration of alcohol to make that work. The CDC recommends hand sanitizers with at least 60% alcohol. But even with 60% alcohol, the CDC recommends using soap if you can. If your hands are sweaty or dirty when you use the sanitizer, that can dilute it and diminish its effectiveness. As for soap, just any old soap works. You don't need soap marketed as antibacterial even. The FDA says skip it. There's no proof it's any more effective. Just be sure to wash your hands for 20 seconds. That's happy birthday twice. Happy birthday, dear. I guess me. Or the chorus to Lizzo's Truth Hurts. Straight to my face. Or Prince. Raspberry beret. Or Eminem. Go, go, only got. Or even Dolly. Jolene, Jolene, Jolene. Just as long as it's 20 seconds. And you're using the ultimate virus annihilator, soap.